Hello and welcome. This is our homework help video for systems of inequalities, word problems. I'm just going to focus on those two for the quiz review. Just review my videos on the systems of equations by graphing and systems by substitution and elimination. I'll just focus on the first 2 pages of this homework. Getting started with systems of inequalities. I'll do problem number 2. So what I want to do is graph each of these separately and then keep the overlap of the shaded region. So y is less than -2. Well, y equals equations create horizontal lines. So I'm going to want to put a horizontal line across my graph at elevation 2. Now, one way to think about this is think about that as slope-intercept form. The y-intercept would be -2, and the slope would be 0. Let's go ahead and connect up these lines with a dotted line because we don't have the or equal to part of that, and then the less than means shade lower. Saying y is less than -2, so we need all the y values that are less than -2. So I'm going to shade down here. Move over to my other equation. Y is less than -4x plus 2. Graph this just like a normal linear inequality. Put a point at our y-intercept of 2. The slope of -4 means go down 4 over 1. Those are the only 2 points that are going to fit on this graph. But that's 2 points are enough to make a line. This one I want to use a solid line because it does have that or equal to part. Just about like that. And now shade below this line. So I'm shading the lower half of this line. You'll see the overlap is this section of the graph down here. So I can erase pretty much everything that's not in that section. Right up to my dotted line here. And only keep that section there. Technically, this line up here should also be erased. Only the boundary of the shaded section needs to be kept. But this is how you see it in most answer keys, with that solid line still extending up here. But technically, it should be gone. There are no solutions up in this part of the graph. It's only down here. All right, let's look at another one. Number 5 was causing some problems for people. Let's go ahead and graph both of these. One has a y-intercept of 1, a slope of -2. I need to connect those points with a solid line because it has the or equal to. And before I go to my next line, I shade for this line. So it is above this line, so I need to shade above this line. A lot of people like to just skip right to graphing the other one. If you do the shading, it makes it much easier to tell where the overlap is after doing the second one. You don't have to think back which line is which. This one, I put a point at my new y-intercept of -2, same slope, so down 2 over 1, or backwards 1 up 2, all the way across the graph. Let's connect them up with a solid line again. And we see we got 2 parallel lines. At least parallel if I put the points in the right spot, but they're parallel. And now I shade above this line. So I'm shading above this line. So that would shade in here, but I wouldn't stop at that line. There's no reason to stop at that line. When I'm doing the second one, it's as if that other line isn't there. And you'll see that the overlap, the darker pink in this case, ends up in this third of the graph up here, that section. So this didn't have any overlaps. We get rid of that strip in the middle, and we only keep the shading above that second line. It's as if this line wasn't even here. This line didn't really have any impact on this problem. So with parallel lines, it's either going to be one of these 3 sections will be shaded or nothing will be shaded, but that's a pretty rare case that would happen. All right, let's look at some of these word problems. Try to do maybe 3 of these, and then we'll call it a wrap for this video. Starting with number 7, Mary is selling tickets to a play. On the first day of the ticket sales, she sold 10 senior tickets and 5 child tickets for a total of $130. So I need some variables here. I know how many she sold, but I don't know what they cost. So I'm going to use S for the cost of a senior, C for the cost of a child, and then I'm going to take that second sentence there and turn it into an equation. 10 seniors times the cost of a senior plus 5 children times the cost of a child equals 130. Second half, the school took in 60 on the second day by selling 5 seniors plus 2 child tickets. What's the price of 1 senior and 1 child ticket? Let's see, one thing. This is already set up to do elimination, not too difficultly, so I'm just going to go straight into that. I was going to say everything in this equation could be divided by 5, but that actually just adds in an extra step. So if I multiply everything by -2, I could rewrite this as at -120 equals -10s minus 4c. Add them together. The s's eliminate. This just equals c. The cost of a child is $10. Take that, plug it back in to wherever you want, whatever looks easiest. I'll probably plug it right there. 60 equals 5s plus 2 times 10 minus 20 minus 20. 40 equals 5s. S equals 5. And now for just this problem, I'm going to write out my answer as a sentence. It is a word problem, so we probably should be answering in the form of a sentence. The cost of a child ticket is $10. Get our unit of dollars. And the cost of a senior ticket is $8. All right. Let's skip down for some this so that one's also selling tickets. I think maybe number 8 is a more different problem than 9 and 10. The senior class at Thunder Ridge and Mount Vista planned separate trips to the water park. The senior class at Thunder Ridge rented and filled 3 vans and 8 buses with 270 students. Mount Vista rented and filled 12 vans and 3 buses with 210 students. Each van and each bus carried the same number of students. Find the number of students in each van and bus. So we'll say V equals the number per van. So it's not the number of vans, but the number of students you can fit in each van. And we'll say B equals the number per bus. So if you take the number of buses and multiply it by this variable B, you'll get the number of total students that we're able to fit in just the buses. Same thing with V for vans. All right, so 3 vans plus 8 buses equals 270. 12 vans plus 3 buses equals 210. Looks like we can do this one with elimination as well pretty easily. We can get a 0 pair by multiplying this equation here by -4. That way that 3 will become a -12. -12v minus 32b equals, what is that? 270 times 4. 1,080. Could be -1,080. Add them together. The vans eliminate. This becomes a -29b. And this here becomes 210 minus 1,080 -870. divide by negative 29, divide by negative 29. So 870 divided by 29 is 30 people per bus. So B equals 30. Students, I guess we could say, or people. They're all students. But these buses can carry 30 people. Plug that back in, I guess, to this one. We'll have 3V plus 8 times 30 equals 270. 3V plus 240 equals 270. 3V equals 30. V equals 10 people. So 30 and 10, actually seem like pretty round, easy numbers. Let's skip down to number 11. This will be the last problem for this homework video, help video. A plane traveled 1,196 miles each way to Abuja and back. The trip there was with the wind. It took 13 hours. The trip back was into the wind and took 26 hours. What is the speed of the plane in still air? What is the speed of the wind? So to figure this one out, we need just a very simple equation from physics. Distance equals speed times time, and that is ground speed. To get the ground speed, you have to take your air speed and either add it to the wind speed if you're going with the wind, or subtract it from the wind speed if you're going against the wind. So we'll use P for plane speed and W for wind speed. The trip is going to be, using this formula here, the distance is 1,196 miles either way. But when we're going with the wind, it takes us 13 hours for our time, and our speed is P plus W. When we're going against the wind, we can cover that 1,196 miles in 26 hours, multiplying it by the plane speed minus the wind. Let's look for a way to simplify these by dividing this one by 13 and this one by 26 from both sides. This will generally help us really simplify it down versus doing some long, messy substitution method. 1,196 divided by 13, that's 92, equals P plus W. 1,196 divided by 26 is 46, equals P minus W. These already have a zero pair with W, so I'm just going to move this one right below and add them together. And I'll get that 138 equals 2P. W's cancel out. Divide both sides by 2. I'll get 69 equals P. Let's go back to maybe this equation here. 92 equals 69 plus W minus 69 from both sides. And I'll get, let's see, 23 equals W, and those are speeds, so they are miles per hour. All right, that's that for this homework video. Hopefully that helps you get a good start. I will see you later.